We are discussing about chapter number 14, which is statistics. So we have normally seen that people are talking about facts and figures. So the information comes in various forms of facts, numerical figures, tables and graphs. And you will generally find them in newspaper, television, magazines and other means of communication. And this can be as simple as uh, how much run being scored in a cricket match, profits of a company, temperature of a cities, expenditures in various sectors of a 5-year plan, polling result. These are all called as the uh, facts and figures. So these facts and figures, which are numerical, there can be non-numerical also, and they are collected for certain definite purpose, is called the data. Now data is simply the plural form of Latin word which is called as datum. So datum plural form is data, which we are going to use a lot in this discussion. So this our world, now we have online the data, we have the data on the book. So we have more information which is available to us and at our desktop only. Now this data is only helpful when we can extract meaningful information from that data. Otherwise the data is just like numbers for us. So the extraction of meaningful information is studied in a branch of mathematics which is known as the statistics. So this statistics word, this appears to have been derived from Latin word which is called status, which means a political state. Statistics came from political state. So statistics in the earlier ages was simply the collection of data on different aspects of life of people useful to the state. Then it began, expanding itself, and the scope broadened, and statistics began to concern itself not only with the collection and presentation of data, but also the interpretation and drawing inferences or conclusion from that data. So statistics deals with collection, organization, analysis and interpretation of data. So these statistics have different meanings in different contexts. For example, we have two sentences here. May I have the latest copy of Education Statistics of India? One more can be, I like to study statistics because it is used in day-to-day life. So the first sentence, as you just saw, the statistics is used in a plural sense, that is meaning numerical data. And this may include various educational institutions of India, literacy rate of various states. But the second sentence, if you go back and see that I like to study statistics because it is used in day-to-day life. So the next one, that is the second statement, the word statistics is used as a singular noun, which means that the subject which deals with the collection, presentation, analysis of data, as well as drawing of information conclusion from the data. So we will be talking about all these aspects regarding this data. Collection of data. So let us begin with an exercise on gathering data. So we have simple exercise or activity for you. Now divide the students of your class, say, in 4 groups, and allot each group the work of collecting one of the following kinds of data. This can be height of 20 students of your class, number of absentees in each day in your class per month, the number of members in the families of your classmates, heights of 15 plants in and around your school. Now, what data which is being gathered, how did they collect their data in each group? So did they collect the information from each and every student? How's a person concerned just to obtain the information? Or did they get the information from some source like available school records? So in the first case, when the information was collected by himself, the investigator is investigating himself or collecting the data by himself, and he has a definitive objective in his mind. The data obtained is called primary data. In the second case, when the information was gathered from a source which is already there, the information was already stored, the data is stored from there, the data obtained is called the secondary data. So if you are an individual, you are you are collecting data, you are collecting the primary data, and if you're getting the data from some other source, it may be internet, it may be book, it may be some other person, this is called the secondary data. So such data which has been collected by someone else in another context needs to be used with great care, because you don't know what is the validity or credibility of that data, ensuring that the source should be reliable, right? So now we have primary data which we by ourselves as an investigator, you can say, we gather, and the secondary data is the data which is we have received or got from some other person or some other means. Presentation of data. This is the marks of 10 students. This is a raw data. It has not been processed. So this is the marks obtained by 10 students in the mathematics test, like this. By this, can you say, can you find out highest or lowest marks? So as you collect the data, then the investigator has to find something meaningful out of it, something easily understandable, right? So if in this data from here to here, we right now, if you make effort, you can get it, but right now we want a way to present the data. So best way is to arrange these numbers in ascending or descending order. Now when you have an ascending order, or you can arrange them in ascending order, this is the minimum one, 25 is the minimum marks, 95 is the minimum the maximum marks. And if somebody comes to you and he or she says what is the minimum marks which has been obtained, you can easily say 25. You can say the maximum marks is 95. So by this arrangement of data, you have range also. 95 minus 25, that is the 70, is the range of the data. The range is highest minus lowest. So just by presenting the data in ascending and descending, you have got immense information which cannot be received or observed from the data which is not being in proper form. We'll take one more example. These are the marks of 30 students. 30 students out of 100 marks they have obtained. Now just recall that the number of students who have obtained a certain marks or number of marks is called the frequency of those marks. So this is the frequency. Let us find out the frequency. So let us see how many students have got 70, sorry, 1, 2 and 3 and 4. So the frequency of 70 is 4. Frequency of 70 is 4. Let us make it more understandable, because tabular form and graphical forms, they are always very good to understand. So this is how the marks 10, 20, 36, 40, 50, 56. So we know that how many number of students have got this mark. So may take 60. So 4 students have got 60. So this is called an ungrouped frequency distribution table, because we just simply marked the numbers or written the number, and how many students have got that marks, we just wrote it here. So this is an ungrouped, we are not grouped it, this is an ungrouped frequency table, or simply a frequency distribution table, you can say. And this is the tally marks in preparing these tables. So what can be done if the number of data increased? We cannot go like this. Can we go like this? Even if we are writing 100 numbers, that is as good as writing the numbers like this. Okay? So there has to be some other way. The other way is to group the data. We have 100 plants, each were planted 100 schools during one Mahotsav. After 1 month, the number of plants that survived recorded like this. And in order to present this kind of data, this is very small data as of now, because you'll be dealing, if you are going to become a statistician, mathematics person, then you'll not be dealing with this data. You'll be dealing with hundreds, thousands and lakhs of data. So this is just an example. So we cannot even deal with this 100 numbers data. So we have to group them, and we have to group them just like this, because we see that thing starts from 20, means there is no number which is less than 20. So we cannot start below 20. So let us start with 20 and just mark the class intervals like 20 to 29, 30 to 39. So 29, see 29 is included here. So the lower and the higher limit are included, and we have some one gap also. I'll tell you what it is. 20 to 29 is the class interval, which is having the length 10. So the size is the class size of class width, you can say. So 30 to 39, how many? You just count on your finger, you will find it is 10. So 10 is the class width. The lower is the lower class limit, the higher is the higher class limit. This is the lower class limit, this is the upper class limit, and 20 is the lower class limit, 29 is the upper class limit. So now let us arrange this data in some other form so that you can get a glimpse of this data, or I will not say information right now, the glimpse of that data just by viewing or seeing or watching a table or a figure. So this is a table. Now we start with 20 to 29, then 30 to 39. We have grouped it. Now we just see, let us take the number which is in between. So we have 20 to 29. Let us find out how many numbers are between 20 to 29. So 20 to 29, let us go and see 20 to 29, 20 to 29, 20 to 29, 20 to 20. This is one number. 20 to 29. I may skip some number, but we'll 20 to 29. We'll go back again. So 20 to 29. Let us see this as column wise. 20 to 29. This is 20 to 29. So we have around 3 numbers here. We have to be very precise. These are 3 numbers here. So let us mark 1, 2, 3. 3 bars like this, and write it 3. And you will do it for every other say class interval. So these are the number 1, 2, 3, 4. This is okay. Now when you have to put 5, just make a cross. So this is 5. This is how you have to make. And just if you have the calculated 5, and after that you have some or more entries, you can just mark it like this. But for 5, if it becomes 5, you have to 1, 2, 3, 4 take and make a you have to cross these lines. Now you can just add them, means this is 3. How much is this? 5 plus 3, 8, like this. So if you add these, this has to be 100. Now you see that you just by taking the class interval and having a tally marks and number of frequency, this data has given us some information. Now you can say from this data that we have a group frequency distribution table. This is because this is a group, we have grouped it. So this is a group frequency distribution table, and now we see that we can get the information that 50% or more plants survived in so 50% and more, 50% more. So 8 plus 18 plus 10 plus 23 plus 12. So this number gives you 71 schools. 71 schools, 50% or more plants survived. So you have an information out of it. And these classes are non-overlapping, because see, 20 to 29 we have taken, and then we have not taken 29 till. So we have taken 30 to 39. So there is no there is a gap between 29 and 30. There is a gap. So this is non-overlapping. And the class intervals can be chosen at your will. Let us now consider this frequency distribution table, which gives the weight of 38 students. 31 to 35, 36 to 40, 41 to 45. So all these have some number, and if 2 new students of weight, say this and this, are admitted in this class, then in which interval will you include them? Now the problem arises is 35.5 lies in between 31 and 35 and 36 and 40. Means 35 and 30, in between 35 and 36, this 35.5 lie. Again 40.5 lie between 40 and 41. 40 and 41, 40.5 lie. So how to add them? So there is a problem. So what we can do here is, we have a very good option. We can take the lower limit of this number, because this 35.5 lies between these two, means 35 and 36. So let us take the lower limit of 36 and 40, this one. Upper limit of 31 to 35, which is 35. Now take the difference. What is the difference? 36 minus 35. This is the difference, so the difference is 1. And just divide the difference, half, 0.5. Now add 0.5 add 0.5 to 35, right? Subtract 0.5 to this subtract 30.5 with 31, add 0.5 to this 35, and now you can change the class interval. So this becomes 30.5. We have taken 0.5 backward, so now this has to become 35.5. So we have subtracted 1.5 here and we have added 0.5 here. Similarly, for the next one, 36 and 40, we have made it 35. We have subtracted 0.5 from here, that becomes 35.5, and now 40 we have increased to 0.5, that becomes 35.5 to 40.5. So in this way we can just change the class interval. So this becomes 30.5, 35.5, 35.5, 40.5. Now if you want to put 35.5, you can easily put in this class interval. If you want to put any other number, say 40.5, this can be considered, because see, this can be easily inserted here, because 40.5 is included here, not in this interval, because the lower one is always included here. So now you know that how can we change the class intervals also depending upon the situation. So now we have a changed or a modified table which can include 35.5, which can include 40.5 if the need arises, and the numbers become like this, and it has to add up to 40 because total are 40. Graphical representation of data. The representation of data by table we have already seen. Now we can just represent them in a graphical form. As we said that one picture is equivalent to 1000 words. If you speak 1000 words, or if you try to explain a map, but if you show a map, the person will easily understand. Okay, so usually this comparison among the individual data, these items are shown by means of graph. We show it by graph, and very easy to understand. We'll see about bar graphs, the histogram of uniform width, of varying widths, and this frequency polygons. We'll start with the bar graph. In this bar graph, you might have eaten the chocolate bar, so it's like this bar. So we have various bars, and you can compare this. So we have a bar, you can say a rectangle. The bar graph is a pictorial representation of data, which usually bars. They are of uniform width and with equal spacing on x-axis, right? And the values of variable, they are shown on the y-axis. The heights of the bar are the frequency, or this depends on the value of the variable. I'll tell you how. In a particular section of some class, 40 students were asked about the month of their birth, and these were the graph which was being prepared. So number of students are like this: 0, 1, 2 till 7, because it goes up to 7. That is why we have made up to 7. We can go up to 70 also. It depends totally on what is the numbers which are being given. And from January to December, see, most of the students are born in August, least are born in June. So this graph, how many students were born in the month of November? Let us go and see November. This is November, so we have 4 students. Second question: in which month were the maximum number of students born? Which we have already answered. They were born in August. Now we have this example: a family with a monthly income of this much had planned the following expenditure per month under various heads. So we have heads of grocery, rent, education, medicine, fuel, entertainment, miscellaneous, and these are all the expenditure. We have to draw a bar graph of this data. So how to draw the bar graph? We need to do something to represent it practically in a graph form. So your unit is the unit which we are taking is 4. So 4 we are taking against, it means 4,000 rupees. Okay. Similarly, this heads, you can say variable on the horizontal axis, we have to choose a scale, since the width of the bar is not important. But we take equal width for all bars and maintain equal gaps between them so that they look good. Okay, so let us the head be represented by 1 unit, and we will represent the expenditure on the vertical axis. So since the maximum expenditure is say 5,000, we can choose the scale as 1 unit, so it can be 1,000 rupees. And to represent our first head, that is the grocery, we can draw the rectangular bar with width 1 unit and height 4 units. For other also, we'll just leave a gap of 1 unit between two consecutive bars, and the graph will be shown like this. We have a grocery, rent, education, all the numbers are being shown here. These are the expenditure in 1000 rupees. So you can easily see and perceive the relative characteristics of the data at a glance. The expenditure on education and education is double than that of medical expenses. Medicine is 2, while this education is 4, so it's double. And we can go for histogram also. So this is simply a frequency distribution table, and this is a form of representation like just a bar graph, but it is used for continuous class interval. Continuous, we'll see, if we have a table say of say 36 students and we have weights. So now these are the weights 30.5 to 35.5, and 35.5 overlaps with this 35.5. We have all these numbers. So how to represent this in the form of histogram? We represent the weight on the horizontal axis on a suitable scale. We can choose the scale as say 1 centimeter equal to 5 kg. And since the first class interval is starting at 30.5, will not start from 0. So we have to make a kink or a break on the axis. I'll show you how. We represent the number of students, that is the frequency on the vertical axis on a suitable scale. So the maximum frequency, as you saw in the table, is 15. So we need to choose the scale to accommodate this maximum frequency. We have to go up to till 15 and more than that, and not very beyond, but just to accommodate 15. We will now draw rectangles or rectangular bar with width equal to the class size and the length according to the frequency of corresponding class interval. For example, the rectangle for the class interval, this will be of width 1 and length 4.5, and then see this is the graph. So this is 30.5, 35.5, this is overlapping, so there will be no gap. The width are equal size, and since till 30.5 there is nothing, so we have made a kink, and we have to accommodate up to 15, so we have gone up to 16. This is how it is shown. So we see that this is a histogram, and there is no gap between consecutive rectangles. The resultant graph is just like a solid figure. This is called histogram, which is a graphical representation of group frequency distribution with continuous class. So if the continuous class has to be drawn, the histogram is the best option. So unlike the bar graph, the width of the bar plays a significant role in its construction. Means the width is very important. So area of rectangle erected, they are proportional to the corresponding frequencies, but the width of the rectangle are all equal. The length of the rectangle, they are proportional to the frequency. So we draw the length according to this. So we'll just take another example. A teacher wanted to analyze the performance of two students in mathematics tests, 100 marks, and looking at their performance, she found that few students got under 20 marks and few got 70 marks or above. Now she decided to group them into interval of varying size, 0 to 20, 20 to 30, like this, 60 to 70, 70 to 100. So she formed a table, and this is not a you can say what should I say, the width are not equal, they are not similar. 0 to 20 the width is 20, 20 to 30 the width is 10, right? 70 and above the width is 30. So this is not the equal class size or width data, but we can still represent the data like this. So what we will do here is, from 0 to 20 the number is, because we have to go up to 0 to 20, so we'll take two bars, this one and this, combine them into one. Then from 70 to 100 we'll take three of them like this, and the number of students can be shown like this. So this is a histogram which is for the data which is being given, and you just carefully, if you observe this data, does this graph really represent correct information? No, because the area of rectangle are proportional to the frequency in a histogram. Earlier we didn't have this problem because the width of the rectangle were equal, but here the width are not equal, they are varying. So histogram does not give a correct picture. So for example, it shows a greater frequency in the interval 70 to 100 than in 60 to 70. In this 60 to 70, it is greater than 70 to 100, which is not the case. See, 60 to 70 is 15, which is low, which is higher than the 70 to above, but this shows something different. So we have to make certain modifications. What are the modifications? See, we have to do certain modification in the length of the rectangle so that the area is proportional to the frequencies. How to make this proportionality? The steps we will follow is, we will select a class interval with the minimum class size. So we have a minimum class size which is 10, right? 20 to 30 you can take. So minimum class width is 10. So length of the rectangle they are modified to be proportionate to the class size 10. For example, when the class size is 20, the length of the rectangle is 7. So when the class size is 10, what will be this? 7 by 20 into 10. So this is 3.5. So in this way, if we perform like this, 0 to 20, the frequency is 7. So the width of the class is 20. So 7 by 20 into 10, because the minimum is 10. Again 20, 30, so this 10 by 10 into 10. And then again 10 by 10 into 10, 20 by 10 into 10, 20 by 10 into 10, 15 by 10 into 10, and 8 by 30 into 10. Let me remind you again, this 10 is the minimum class width, which is 20, 30, 30, 40. So if you subtract them, you will get 10. So now you can again remake this table, and this is the proportionality, the proportion of students per 10 marks interval. Now this is showing the exact picture. So this is the first part of the discussion of statistics. We'll be taking one more. Till then, thank you so much and take care of yourself.